Let's consider some of the strangest planets we've discovered so far. First on our list are the gas giants, Jupiter and Neptune, known for their intense weather patterns. These colossal planets, despite being significantly farther from the Sun and receiving much less heat, have some of the most violent and chaotic weather in our solar system. But how is this possible? The answer lies deep within their cores. Gas giants generate more heat internally than they receive from the Sun. This internal heat is driven by the intense pressure and gravity of their massive cores, which create convection currents in the atmosphere. These currents, in turn, power the storms and weather patterns we see on the surface. Take Jupiter as an example. It's a powerhouse of internal heat, producing more than any other planet. This heat fuels Jupiter's year-round storms, including the infamous Great Red Spot, a storm that has been raging for at least 300 years. Isn't it fascinating how these gas giants create their own heat and weather? Moving on, let's explore the ringed beauty, Saturn, another planet with an interesting heat source. Saturn, much like its gas giant relatives, gives off more heat than it soaks up from the Sun. You might wonder, where does all this warmth come from? The answer lies in the peculiar weather of Saturn. The planet experiences what could be termed as helium rainstorms. Yes, you heard it right, helium rainstorms. As helium condenses into clouds within Saturn's atmosphere, it begins to rain down towards the planet's core. This rain of helium creates friction as it falls through the denser layers of the planet. This friction, in turn, generates heat. It's as if Saturn has its own internal radiator, keeping the planet warm and toasty. This internal heat has a profound effect on Saturn's climate and seasons, making it a truly unique member of our cosmic neighborhood. Imagine a planet where the rain itself generates heat. Next, we have the lone wanderers of the universe, the rogue planets. Unlike their conventional counterparts, which are held in the gravitational embrace of a star, these celestial nomads have no star to call home. They meander through space, free and unbound, adding a unique twist to our understanding of the cosmos. So how do these solitary travelers come into existence? Theories suggest they might be created through planet-planet scattering, a cosmic game of billiards where gravitational interactions between planets cause them to scatter and sometimes even get flung out of the star system. Other rogue planets might be the survivors of a more dramatic event, such as the ejection from their original star systems due to a stellar explosion. These intriguing planets, untethered and wandering the vast expanse of the cosmos, challenge our traditional notions of planetary formation. Rogue planets are a reminder that not all planets need a star to exist. Finally, we have some truly exotic exoplanets that defy our understanding. Let's start with Kepler 78b. This fiery world orbits its star at a blisteringly close distance, so close that it completes its orbit in less than 9 hours. This proximity contradicts our current theories of planetary formation, leaving scientists scratching their heads. Next, there's Kepler 10c, a rocky behemoth twice the size of Earth. What's peculiar is that it lacks a thick atmosphere, a characteristic that goes against our expectations for a planet of its size. Lastly, we have HD 1069006b, a gas giant 11 times the mass of Jupiter, but located at an orbit more than 20 times the distance of Neptune from our Sun. Its extreme remoteness raises questions about how such a planet could form so far from its star. These exoplanets prove that the universe is full of surprises, constantly challenging and expanding our knowledge.